So how many of you tried the question that I posted in the email group? The question there is, we wanted to write a program which displays the contents of an array. But the problem is, we don't know the type of the elements in the array. So if we don't know or we know the type of the elements in the array, but then we may have to write. Does anyone have the code so that I can quickly, which you can share it, the C code? Yes, so, or we can just do it, it's not a big deal. So let's write it together. Int IRR one, okay, 3, 5. So last year, when your seniors are getting stressed out before an exam, so I did 10 minutes of relaxation, voluntary relaxation exercise for them before the exam. So some of them found it to be useful. Not offline, online. So here we can see that we are writing a program function to print an integer array. Why can't we use the same? Why can't we just use the same function to print double data also? Sorry, this should be not int d array, or maybe let's use float. Why can't? Because printf requires type of data. Okay, cout less than data I. Okay, so printf requires type of data. So that is and also the parameter type also, it has to be appropriately set, right? Yes or no? Because that if you look at the function signature for print int array and print float array, the function signature also changes. So now we have print int array data. Sorry, yeah. So data and size is 3. Oh, sorry. Yeah. What is being passed to the int array function? What is being passed? What is being passed to the int array function? Base address of the array. Exactly. By this time, all these ideas should be very, very clear to you. Base address and size, of course. Okay, let's compile this code. CD GCC where is this stored? Okay, I think I have to store it, save as or CP. Did I use C In which directory I have written last time's code? Right there itself, .cc. Oh, there is a C++ folder. No, not here. CP, it's okay, doesn't matter, but okay, got it here. Let's write it here, display dot. Oh, okay, replace. Why CPU hog? Siege G++, what is the program name? I forgot. Displayer. GCC display GCC display array.c .a.out. Okay, so all good. Oh, you're all waiting for crashing the CPU. Okay, we will see. Let's the last class of the semester we'll do that. Come up with your programs to crash my CPU. So you see, there are two reasons why we cannot have a single function to display both integer data and float data. One reason is, of course, printf requires a different format specifier, and then the second reason is the function signature, the parameter type. When you are passing an integer array versus floating array, floating point data, we have to do the appropriate typecast. Are you with me on the two reasons why we cannot have a single function to display both integer and float arrays? Are you all with me? Okay, I hope you are with me. So now we will write the same code, display array.cc. We will write the same code and write code in C++. Okay, maybe I should do rename. I think even CC also works maybe. IO stream. Okay. So we have to use hash include IO stream using namespace std, and then what we have is we'll copy this and we say we comment out all this code. Print array, and then what should we have? Template class T, and then we say T data. So cout less than data I less than and then are you with me on this code? Does it make sense? So I was so excited to see this small example, but which illustrates the power of two ideas in C++. One is generics or using templates. That is one. The second idea is operator overloading. Now, when this operator cout this less than, this is a binary operator. This is a binary operator. And this binary operator, what So the same operator, it has different meaning depending upon, yeah, it is a binary operator both in C and what is the default semantics for less than? The first semantics that you learned for this one. Yeah, it is a left shift operator. Okay. So it's a binary operator. And now this operator, it is overloaded. So it has now two operands. It has two operands. So this left one, this is the type of this object. The type of this is what is called as a O-stream object. Okay, don't worry about it, but think of it as some data type. And the type of this, it depends. The type of this, it's like, for example, in one case it could be an integer, in some other case it could be a float, so on and so forth. So depending upon what the parameter, what the operands are, let's say we fix the left operand as O-string. So if the left operator is O-string and the right operator is of type int, then what happens is a chunk of code, which knows how to displace integers will be invoked. On the contrary, if it is, and that's what exactly happens in printf also. When printf looks at %d, it invokes that code within printf which knows how to display integers. And when it looks at %f, printf invokes code within itself, that chunk of code which knows how to print floating point numbers onto the screen. So here we are telling printf what code it should use, what is the chunk of code that it should be invoking within printf. Whomever has written printf, internally they may have something like int underscore printf, and they may have float underscore. They can have sub functions like float underscore printf, and these functions, they know how to print integers and how to print float, etc. So this operator, depending upon the data type of this operands, it will appropriately invoke the corresponding routine, the corresponding function. This is a very, very powerful feature, and this is called as operator overloading. Operator overloading. Not only that, so we will see this displays this data onto the screen, and then this whole operation, it returns a cout as the result of this thing, as the result. So before I get there, I want you to make one comment, because when I talk about it, I know it will take a different direction. Some of you may be confused. So let's say in C, when we have something like 1 plus 2, and if you draw the expression tree for it, it is 1 plus 2. And let's say if you have something like 1.0 plus 2.0, then the corresponding expression tree is 1.0 and 2.0. So here this is an int. This is also of type integer. So the addition, from your DSM course, the way you add, the algorithm to add two integers is different from the algorithm to add two floating point numbers, because the representations are different. So operator overloading is there in C also to some extent. Okay, but it is not there to the extent that is visible, that is available in C++. Do you see why there is this addition operator? It is overloaded. So depending upon the context, the appropriate addition routine will be. So like, for example, here maybe int underscore add instruction could be used. So here float underscore add instruction could be used. I hope you understand this concept. This is operator overloading is there in C also, but it doesn't take its full form or shape in C programming language. So now, when we have something like, let's see, 1 plus 2.0, then what happens? No, it's not 1% is not, it's not operator overloading. Yeah. So 1 plus 2.0, when it is there, then interesting thing happens. Okay, let me keep this one here itself. 1 plus 2. I will say yeah, 1 plus 2.2. So what happens is there's an implicit conversion happens, and the way the implicit conversion happens is there will be an int to float operator that will be applied on 1. Okay, so an int to float operator will be applied on 1. So the result of applying this this function on 1, this is equivalent to static underscore cast that we have seen in the last class. So this returns value 1.0. So now 1.0 plus 2.0, then you are adding two floating point numbers, then a corresponding floating point addition circuit will be in. Do you see? This is the implicit typecast that is happening. This is where the implicit typecast. Typing is a very, very important idea. Type system, this is very, very important idea in programming languages. Yeah, it's equivalent to the same. When we do an explicit typecast, that's what happens. You can do, instead of implicit, you can also do explicit typecast. Float 1, then also the same thing will happen. Are you all with me so far? Doing all right? You are learning some advanced ideas, but these are very important. Okay, so now for the time being, so as I told you, truly, I learned C and I learned read C++, but didn't do enough programming in C++. And I didn't think about how different things are implemented, and that enough background is not there. So as I was preparing for lectures, I was thinking about some of these ideas. And one thing that intrigued me is this cout. This so the cout function, the cout thing, I was wondering how is this going to work? So because we can have complex statements, no, like for example, cout less than, no, something like n equal to something n. So in some other programs, you may see this. No, I'm just, this doesn't make sense in this one because we don't even have m and m variables. So I was thinking, so if so on line number 13, so I was wondering what exactly, when we do printf here on line number 20, we know that we are passing a string as a parameter and we are passing some other data here. But then here in cout, what exactly is happening? We have all these things. How does the compiler, I'm not able to interpret it properly. Okay, I'm not able to interpret properly. Okay. So thank you, Abhinav. You said you're not understanding anything, but you gave a very good answer. So then today or yesterday I learned what happens is the way the cout, this double shift, this left shift operator works on O stream and any other data type is, after it performs this cout, so this operator, what it does is when cout, so cout, what it does is it prints this data onto the screen, and then the result of this binary operation is this O stream object itself, which is passed up here. Okay, this is a bit confusing. So, but for the time being, just think of this as like cout is some special display function. It's not a function, it's an object. What is an object? You didn't see what is an object yet. So those of you who are familiar with C++, they may know, but otherwise, just think of it as it is some special object. Just think of it as some special object which can display things. The result of applying this, the result of this binary operator, there are two things that are happening as a result of applying this binary operator on these two operands. The result is cout itself. The result is cout itself, result. So this is one. The result is cout itself. Like for example, if you say what is the value associated with this node, what do you say that is value that is associated with this node? 1 plus 2 is 3, right? That is the value that is associated with this node. And the value that is associated with this left shift operator is cout object. But then there is a second thing that happens, that is the byproduct or side effect, not, but it's an important side effect. So the side effect is, so this data I gets printed onto the screen. Whatever the contents, this gets printed onto the screen. So this is very important observation. I don't know how many, again, I don't, unless you thought about it before, you may not quite appreciate what's going on here. So, but if you see what happens here, if you see what is there on line number 13, what is there on line number 13, so less than cout. So this left shift operator, it is applied in a left associative manner. That means it doesn't just think of it as some special object path for the time being. We will understand, it takes a bit more insight to understand it. Okay, so what is important though is, let's just focus your attention here. This left shift operator, it is a left associative operator. What is left associative operator? If you are doing 1 plus 2 plus 3, we add 1 and 2. If addition is left associative, so you first add 1 plus 2 and then you get 3. And then whatever the result, you add it to 3. So that is, if you look at it in terms of an expression tree, so what you have is plus 1, 2, the result you add it to 3. This is left. This is because addition is left associative. Do you understand this left associative idea? But on the contrary, if it is right associative, it's not the case. If it is right associative, then what happens is we add 2 and 3, whatever the result that we get, we add it to 1. This is right associative. So I hope you see the difference between left associative and right associative. Now this left shift operator, it is a left associative operator. Left shift is this is left associative. Okay, it is left associative. So because of that, the expression tree associated with this one. So the expression tree associated with this one is you do this and then left shift, we do a 10 and then left shift, M equal to left shift, we have M. No, this is left associative, right? We are doing association from the left. Are you all with me here? And so what is the effect of the bottommost tree here, bottommost part here? So what are the two things that happen? What are the two things that happen here? What is the value of this node? What is the value of this node? One is n equal to gets printed, and the value of this node is C out. And now C out applied on n, what happens? C out applied on n, what happens? C out via n gets printed, and what is the value of this node? C out. And what is the interesting thing here? Because of the operator overloading, here here code corresponding to printing a string will be invoked, and here code corresponding to printing an integer will be invoked. But the operator is the same. Similarly, now after it is done, after now C out when so to the left shift operator, C out is the left operand and this is the right operand. So what happens? M equal to gets printed onto the screen, and the value of this node is C out. And then similarly, C out applied on M gets printed onto the screen, and the value of node is C out. This is how the evaluation of this expression that you are seeing on line number 13 continues. Are you all with me? And my claim is, can you disprove through this analysis that left shift cannot be a right associative, cannot be left shift, cannot have right associative precedence? Can you disprove that? Can you prove that it cannot have? How can you prove? What is the expression tree? Can you draw the expression tree? Exactly. So when you do this right associative thing, when you try to do the evaluation from right side, so this thing, Anaika has got it perfectly right. This doesn't mean anything. Okay, this doesn't mean left shift, one operand is string, the other operand is integer. It doesn't have any definition as a part of C++ language semantics. So what happens is it will crash. It doesn't matter. It's not Arabic or anything. So how does it matter? So this is going to be. So let's say I have a question for you. If it is for our Arabic people, how would you design this output language construct? Very good question. Maybe it's a good exam question. Okay, but right now, how many of you understood why it cannot be right associative? If this left shift is right associative, then when you apply string and on an int, there is no semantics for this left shift operator. And because of that, it crashes. So that's the reason why it cannot be a right associative operator. Okay. Let's move on, and maybe we can revisit this lecture again and see, catch up on ideas which you didn't quite get. So now, so one more interesting thing. Let's say we want to compute the area dot CPP. Okay, area of a circle. And so again, hash include IO stream. Okay. And between in C++, the main function cannot have void return type. It need to have int return type. So I put void return type and it compiled. Template is a parametric data type. It can be anything. Okay. Great. So let's see. Yeah, so float radius all right. Yeah, let me. Okay, great. Thank you. Return radius star. We can perhaps keep inline here. Okay, does this code work? Or require radius? Radius. Okay. So now let's compile this program gc's g++ area.cpp compiled, and let's say if I enter 10, it is showing area. Okay, IR square 100. Okay. So the point of this question is, of this problem is, since Abhinav didn't like my value of pi as parameter, so he will replace it with 3.14. Okay. So now instead of pi being 3.17, it will be, 3.14. That's the point. So it is possible. So like, for example, earlier, let's consider these two statements. Area of circle, yeah, so I'll put my, let's say I'll put my version. Okay, using Abhinav version. So there's a default 3.14, and yeah. So this is the point. So there's a, so it is possible to have default parameters. Now the value is not being overwritten. It is possible. So it is possible to have a parameter with default value. So pi is a parameter with default value. So if you don't pass pi, then the second parameter, the default value will be taken. There is no value that is being overwritten, I mean, in the sense. And what is the parameter passing mechanism that is being used? Call by value. Okay. So now, so let's move on. And but if you don't give a default, then it will have an error. Yeah, that's true. If you don't have this one, then it's an error. That's true. Okay. If pi is a macro, the story is completely different. It is textually replaced. So the story so far, if you see, is in C programming language, or for that matter, in any programming language, we have what are called as primitive data types. What are called as primitive or native data types. What are the primitive or native data types? Char, int, float, double. And then on these primitive data types, okay, like for example, if you see, there is a set of operators that are mathematical operators that are naturally defined: addition, subtraction, multiplication, division, etc. So, but let's say, no, you are working on, so complex numbers is not, let's say you want to work on complex numbers, and complex numbers are of the form 2 plus 3i, or 3.1 plus 4.3i, so on and so forth. And let's say we are working on set of complex numbers. So the domain you are creating, you are now working on a new domain. Thus, the new domain can be a set of complex numbers, or it can be a set of matrices, or it can be the set of images, or it can be a collection of polynomials. So you can create, you can have new domains on which you would like to work. Like for example, if you are working in coding theory, some of ECE students, you will learn coding theory sometime in the next couple of semesters. When you work in coding theory, you work a lot with polynomials. So when you work with polynomials, no, that is a domain. The objects that you are working with is polynomials, and there are natural addition, subtraction, multiplication operations defined on these polynomials. So we want the language, we want to give that kind of extend the language in a way so that we can create new domains beyond the integer domain, floating point domain, double domain. We want to create new domains. That's number one. Not only that, we want to give some nice operators. We should be able to define operators on these domains. Okay, so that is the goal, and that's how the language should have that ability to give that feature to the programmer. Okay, so let's say, you may say, why C is in some sense lacking here. So why C is lacking, if you think about it? Did anyone wrote code for don't save? Okay, save. So let's see. So if you are working in C, so this is, so let's try to write a program for working with complex numbers. So the first thing is we want to define so new data types, new objects, and in C it is possible, in C programming language it is possible for us to define new languages. Okay, so it's not like we cannot do it. Now we are defining a new object type complex, and there are two parameters: float, real part be a complex number, float imaginary. Okay, all right. So does this definition make sense? Of course, we have to write operations. How will the computer know that no, complex means complex numbers, and so your notion of complex number and my notion of complex number could be different. So we have to define the semantics also, of course. So, but first let's compile and see if I got the syntax right, because I don't remember the syntax of these things. So GCC complex.c. Okay, but otherwise the type definition is good. Are you with me now? Now we are extending the domain by including a new domain, new data type, that is complex. Very much true, Abhinav. Yeah, and then so let's say you have an add operation. So complex add, complex A, complex B, and then we have something like complex T. So T dot real is equal to A dot real plus B dot real. Control V, T dot imaginary dot imaginary B dot image. Okay, and then we return T. So let's say, like we have complex Let's see how it works. I didn't write this program before. Complex a dot real. The whole value will be returned. A dot real is 1.0. A dot imaginary is 2.0. Or is it? Okay. So maybe, yeah. So there is shorthand version of. I'm adding two complex numbers. Whatever the code I am writing, you are understanding, right? At least someone said add printf sum. You guess, Sanika, what do you think it will be? %f. Yes. %f, right? Addresses makes more sense, huh? Let's see how this thing comes out, and then we will discuss. C dot. You know, sometimes I write code directly here so that I can get surprise myself. Add implicit declaration of did you mean capital R. Okay, now let's see what happens. What do you think the output will be? /n. So as you can see, we added two complex numbers. One is 1 plus 2i and 2 plus 1i. When we add them, we get 3 plus 3i. So what happens is this whole value is copied back. The whole structure is copied back. Remember, t is a local variable, and the memory that is allocated to t will be lost. You cannot access that. Are you all with me here? That the memory for t is released after we are out of add. But the whole, that 8-byte value is returned back to on line number 7 as a result of this function. So why did we write this code? If you see what you would have preferred, you would have preferred C is equal to A plus B, right? Rather than C is equal to add A comma B. Yes or no? So line 29 is preferred than line 28. It's a more natural thing. You are kind of absorbing, you are incorporating complex numbers into the programming language space. Okay. So line 29 is the preferred way of writing code. Okay. But then in C, it is not possible. It's not possible to have line number 29. And one interesting thing about line number, but in C++, it is possible because when we have this thing plus AB, and then you know the type of A is complex, and you know the type of B is complex. And when you know the type of A is complex and type of B is complex, then what happens? We can, if we overload addition operation saying, hey, if you get two complex numbers as parameters, then invoke a complex addition operation. Does it make sense? Can we use overloading in C++ to define a new addition operation for complex numbers? I got a very bad example, but super good. Bad, but interesting and appropriate example for overloading, but I'll not use it here. Okay. Um, oh, yeah. So anyway, well, yeah. So this is what we want to do. We want to incorporate. So we want to incorporate addition operation. And one more thing also is line number 30 is painful. Now, whenever you want to print a complex number, so one way of doing it in C is printf sum is percent capital C and going and say print C, where percent capital C or percent small c is indicating, oh, percent small c is complex, right? So let's see. So, so, but then the problem is if you want to do that, you have to go and modify the printf code. Yes or no? Because you can keep on defining new and new data types, and you cannot, you have to keep on introducing format specifiers, and you have to go and change printf code, and that's not a viable option. Perhaps, just like if you have something like cout less than C, then automatically, that 3 plus 3i gets printed, then that would be fantastic, right? So that is, so these are the things that we would like to get through this. What are the things that we would like to have in our programming language? The first one is the ability to introduce new data types like complex, polynomial, or whatever you have. And then the ability to define native operators, natural native operators on them. That is 2. Number 3 is we would like to have, like for example, we called this function display. Where is this function? Display array.cc, right? So we should be able to print complex numbers just like this. We should be able to pass here something like, we should be able to say, instead of print float array, this is okay. We didn't compile this code, but so here we will just have print array, print float array. We should have something like complex CARR, and then do initialization, some way of initialization, and then finally we should be able to say, hey, can you just print the complex array? We should be able to do it. So then our system becomes, then we are extending the natural semantics or natural facilities that the inbuilt data types, primitive data types, native data types have to the new domains on which we are working on, to the new domains we are working on. That's our goal. All right. So are you all with me? Are you able to appreciate the problems that we are raising? So now you are just not, programming is just not thinking about some logic and complex things. This is about software architecture. You are not mere programmers. No, you want to become software architects. No, you should be able to build large systems. Then unless you use these cool ideas in a very clever fashion, you will not be able to build systems which are great. You will be able to build average systems or substandard systems. So we will stop here. In the next class, we will solve this problem. Is it okay with you? So you understood the problems. In the next class, we want to solve this problem. I can possibly go for 10 more minutes, but I think I'll stop here. Okay, I'll stop here and we will start afresh in the next class.